is Lindsay Petley-Reagan. I'm a scientific simulation director at Labster in Copenhagen. And today I will talk about, as Charlotte mentioned, a toolbox, which is both a software and also kind of mentalware for growth and holacracy that we use at Labster. So first of all, I'm not a designer, I'm not an engineer, I'm actually a cell biologist. I studied cells that come out of the brain and migrate along the nerves to the places where they attach to muscles. And this process involves a lot of signaling. Every time the cell would bind to the neuron that it is following, there would be this whole host of internal signals that would go down and cascade in the cell, and they would there would be proteins that are binding to each other, activating each other, inhibiting each other, and this would eventually result in the growth, the movement, and the maturity of the cell. And so I have always found it kind of interesting, like, how did I get into this now I'm at Labster, and I'm a person who is really involved a lot with the workflow of how we all work together. And I enjoy this a lot. And I've wondered myself, like, how did I get here? What is this? And also I have, at the same time, realized that it's very similar to cell signaling, where you have all of these processes in a company that are inhibiting each other. They have to happen in a specific sequence of events. Some are more important and higher priority. And so it's kind of interesting. I think of companies a lot as cells that are migrating along their journey and trying to figure out how to grow and make sure that everything goes according to plan. And then I also got really interested in virtual reality when I was working for an art science festival and saw this way of getting inside a cell and being immersed in the cellular environment, just in terms of teaching three-dimensional topics such as cells and biology in general. So that has led me to where I am now at Labster. And Labster is a company based in Copenhagen where we have, we design virtual reality science simulations. So they're about 10 to 30 minutes long, and they vary in topic between chemistry, biology, and physics. And they are at the high school and university level. And so it's really a hybrid approach that we have, where it is, we mix the experimental protocols that a student would have to know when they go into a lab with the kind of core biological concepts that they need to know what's happening when they do these experiments. And in addition to that, we have some quizzes along the way to help teachers have some feedback of where students are kind of confused and where they're excelling. And this is an image of inside one of our simulations. And a lot of our simulations, that one didn't seem to show, but our simulations begin with a storyline, which can have an intro scene that is often, we have gone to exoplanets before, we've gone to safaris, the storyline provides a setting, and then there's often a mystery or a mission that the student has to solve by completing some scientific experiments. And hopefully by the end of the simulation, they have completed this and are successful and have learned along the way. And so I work as a scientist on a team with artists, 3D artists and 2D artists, as well as developers, to design our product. And when you're talking about virtual reality, something that Rory mentioned is kind of testing products as you go, and virtual reality, especially scientific education, virtual reality is definitely an exploratory field right now. Everything that we do, we want to get feedback right away from teachers and students to figure out, does this fit in with your curriculum? How useful is this? Where and how exactly do you use this? Is it a replacement for labs? Is it kind of like a pre-lab? Is it a test? Is it for teaching? So we are constantly doing the cycle of making a product, testing it, and maybe editing it a little bit every time we get feedback from customers. So it's very relative to what, relevant to what Rory was talking about. So on our team, we have, as I mentioned, I work with artists and developers, and you can imagine that we have very different skill backgrounds. And one of the challenges of working in a team like that is that we can't take on each other's jobs. So if somebody is overloaded at a time with a lot of 3D art, the developer and the scientist cannot really help them out by taking the jobs. And so it's really important that we have everything set up in a way that everybody's workload is manageable at the same time as having things ready in the correct order. Because there's a lot of things where one person will have to do something and then it will have to go to another person and then go to the next person. And so the order of all this sequence of events has to be perfect. However, one of the advantages of being a very diverse team is that, for example, when we have a brainstorm session before we begin any simulation design, it's really great for me as a scientist to present to my team of developers and artists the kind of 3 to 5 minute summary of the scientific topics, such as cellular respiration. How does a cell produce energy? It's really interesting when I present these ideas to non-scientists to kind of get their ideas back of what this kind of a metaphor for how this plays into their life. And often the ideas that I get from my team are, they become part of the simulation, they become part of the storyline. For example, I was designing a simulation on conservation of energy, so kinetic and potential energy of roller coasters. And one of the artists said that it seemed a lot like money exchange. Like you have money, it represents value, you exchange it for a different type of an experience, but the value of it stays the same. And so we had this whole kind of metaphor going throughout the simulation. And so I think it's a matter when you work in a diverse team to see where you can actually use each other's different skills and take advantage of the diversity rather than let it hinder you. So our team here, as I said, I'm based in Copenhagen, where there's a lot of the scientists and the operations team. And our team also has a lot of artists and developers in Bali, and also some in the Ukraine, some in the UK. And we are currently growing a lot in Boston, where in the last 6 months, we've gone from about 5 employees to 42, and they are mostly in sales. So not only are we a very skillfully diverse team, but we are culturally diverse and located all around the world at the same time. So to get into how do we manage to work together as such a diverse team, and how do we manage to kind of keep all of our values the same, even though we are separated physically and digitally. Something that is really important to start with about my company Labster is that we use Holacracy. So we use Holacracy, which is basically a way of, it's a flat hierarchy where we have roles instead of job titles, so that the authority is distributed amongst a selection of roles within a subcircle of the company. And so any decision that affects how that circle functions is a democratic governance decision, and actually it's often a unanimous decision is needed to move forward. And the way that you kind of make these decisions is if no one can find any way that an experimental idea is causing harm to the company, then you go through with it. And you allow experiments to happen. You can create new roles as the company grows and has new responsibilities. And this adds value and allows for the freedom of experimentation in your company. And something that is really important is that I can mention exactly that this does help with that 42% of people who feel like they have their hands tied by the processes at a company. At Labster, since your team is responsible for the way your team works, it is a very quick, every week we're changing the way we work, because somebody comes up with a new idea and we say, hey, I think that this works really well. And everybody says, oh yeah, that definitely would be great. Let's implement it right now. And there's no authority figure that you have to go through to get that approved. So that really enables fast company growth. all over the world for Labster, where the teams can kind of grow and duplicate as fast as they need without any management having to make any decisions about that. So another thing that I haven't really read about anywhere about Holacracy, but something that I have personally felt was an advantage of Holacracy, is that with all these different roles in a company, rather than starting at a job and having the same job for years and wanting more responsibility, feeling like you want to grow a little bit, but waiting for that promotion, it's kind of like you get a little bit promoted every few months and you get a new responsibility here and there. And if you take on a responsibility and you feel like, oh, actually, I don't really want that one, I'd rather focus on this other one, you kind of just shift. And it really allows you to go in the direction that you want to take your personal career, whether that is all in one focus, or maybe you want to go in two different directions, but you can kind of have a 50% of this and 50% of that. And I found it very rewarding that in the last 2.5 years, I can really feel I grow a little bit every few months, and you're not waiting to kind of learn something new. And so something that we use a lot is Confluence, which is a software made by Atlassian, which I'm sure some of you have heard of. And it's basically an online encyclopedia that is for your company. And it grows over the years. It's contributed to by everybody. And so it allows, basically, if there's a question that somebody is wondering and the answer is not already somewhere in our Confluence pages, then it is that person's responsibility to figure out what the answer is and make it available for any future people who are wondering the same question. And so this really changes an onboarding process. I was a little bit confused when I started because I was used to jobs where, you know, you have a supervisor who is kind of working with you for 3 months, you're shadowing people. Whereas here, someone can sit down and do the job right from the very beginning because everything is there. They just need to follow the steps. And of course, there is lots of support, but it's really amazing how no matter what you have an answer about, you can find it here. And it also develops a lot of responsibility for individual team members because people are given responsibility of kind of making sure that certain Confluence pages stay up to date. And this allows them to develop an expertise within the company that they are then responsible for. And again, it's a way of empowering your employees to kind of know and be the expert on a certain topic. And again, this encourages experimentation because anytime a new idea gets tested and then is found to be valuable, that person can then make a Confluence page about it and share their learnings with everybody. And so there's many other uses of Confluence, but those are the ones that I find are the most helpful to Labster. So another Atlassian software that we use a lot is called Jira. And I'm just gonna have a glass of water. So Jira is basically a way of having big projects divided into a lot of functional units. So small units that are then, you take a task and you can assign it to a person. There's a big description of what details go with that task. And then, and so these ones that you can see on the screen are all the like automatic tasks that get created every time we create a new simulation. And so it's a way of dividing projects into functional units. And these tasks can then go through different statuses from like backlog to do, in progress, testing, done. And one of my jobs at Labster is to create these workflows for different teams and different projects. So I'm going to show you a few of the examples that we have at Labster for different functions. So the first one is an escalation bug, which is if a customer notices a mistake or a problem or something's broken in one of our simulations, that's a really big deal for my company. And so we have this super fast process where as soon as the ticket is created by one of our customer representatives, it goes into this new status and it is kind of linked with Slack so that everybody within that escalation team gets notified right away. Oh, there's been a bug reported. Okay, who do we assign this to? What is it? Is it really high priority, or is there some other reason that this bug is happening? And then once it's in new, it can go either to backlog, to do, and it goes to in progress. And then once it is fixed by the developer or the scientist, then it goes to this awaiting confirmation, which is to make sure that it is fixed, like really fixed in the simulation, in the good production copy of the simulation. So that's escalation bugs. A totally different workflow is when how we create an entire simulation. So this begins with scoping the simulation, which is done by figuring out the complexity points that are required for that simulation and the learning goals. And then the simulation goes through the processes, goes through initial phase, which is the brainstorming session, writing the flow of the whole simulation. And then it creates all those automatic tasks that I showed you earlier. And then the simulation goes through the different phases and until it gets tested by our QA team and then launched. And so this is one of the main workflows that I use on a regular basis. A totally different one is this art asset creation. So if a scientist requires a new microscope to be made for one of our simulations, or a new type of glassware, a new machine, then they request an art asset, which has to be, all the details need to be made immediately so that future scientists like myself can figure out, do we already have this art asset in our library? And then it gets gray boxed. So this is also part of the iterative workflow that we use. Rather than waiting for the final good copy, the artist will gray box it and provide the functionality of it to make sure, so that the scientist and developer can make sure that it can be used the way we want it to be used in the simulation. And then it goes through the final drafting and the testing, which is where our art director figures, kind of does a final scope of or a quality assurance of the 3D asset to make sure that shadows are correct and all these details, textures. I've learned so much about 3D assets working at Labster. And the final workflow that I thought I might show you today is one about our idea roadmap. So here, instead of statuses being to do or testing or in progress, we have it as the quarter that we're working in and what is suggested for that quarter. And so this is a way of kind of easily moving tasks around. And this is a Kanban board where you can simply move tasks around in here. So the final thing that I will mention about how my company works together as the diverse and very locationally global team that we are is by using squads, which are something that we've implemented in the last year and have been really astonished by how well they work in our company. I know that they are they're used by other companies such as Spotify, and they have been proven to be quite successful in developing team dynamics. And so, as I mentioned before, is that we have these scientists, artists, and developers that all work together to create our simulations. And so kind of like Rory mentioned, one thing that I've noticed is that to become that T-shaped expertise is really important here. I don't have to know how to do a developer's job, but I have to know how to talk to him and how to communicate. And it's important that we all have a shared library of words that we can use to talk about our simulation development together. And squads are a way of, rather than having 30 people that are dispersed amongst being artists, developers, and scientists, we have separated ourselves into, so let's say here we have 2 artists at the bottom, 2 scientists, and a developer. And we've made ourselves into these big functional units. So now we are 5 squads. Each one is a functional unit that can just make a simulation all by themselves. And so this has become a really great way for basically planning, because anytime we need a new simulation, instead of trying to figure out which artist has time and which scientist and which developer does it work well in their schedule, now it's just, hey, squad 4, this is your responsibility, and then squad 4 can easily put it into their calendar. Oops. Can easily put it into their calendar here, where it's a lot easier to manage a schedule with only 6 people. Somebody's going on vacation, and so you can just move things around in the calendar. And as you can see, the color scheme here is for simulations that are like the same simulation. So the artist has to work on something, or let's say me, the scientist, has to work on something, and then it goes to a developer later. And so it's been a lot easier to time manage and to be a lot more flexible and to prioritize important things. Simulations that have to be released by a certain date versus simulations that can be delayed a little bit. And so, yeah, this is, and the final slide that I was going to show that is not here was just about how squads really help with our team dynamic. That it is difficult when you've never met a lot of the people that you work with on a daily basis. So it is nice to at least get to know a few of them kind of intimately, and the squads can change over the years, so you get to know different people every year, but it does definitely help our amazing team stay very connected and to keep all of our values the same. So thank you very much. I'm happy to take any questions.